Hello students, in previous lecture we have studied 14 different types of unit cells. Then see here, today we are going to study about the detail about the unit cell, and the unit cell which is a repeating basic pattern of the crystal or that substance. Lot of unit cells which are stacked in the crystal lattice. That means those unit cells which are closely packed or closely stacked in three-dimensional pattern, and it forms the crystal lattice. Then all of you are studying about the different 14 types of unit cells are present in different crystals of the crystalline substances. Then we will study about the detail about one by one about that unit cells. Then first of all, see here, we have to discuss on the crystal systems and the unit cells which is present in that crystal or crystalline substance. Then first of all, we will discuss about the cubic system. Cubic system, that is cubic type of unit cells. All of you have studied about the cubic unit cell. That is, see here in this diagram, it is a cubic type of unit cell in which conditions are there. A is equals to B is equals to C. That means there are A, B and C are the three edges on X, Y and Z axis. All of you have studied about that in previous lecture. See here A is a edge length. Here B is a edge length. And C is a edge length. And here three type of edges of this unit cell, that is cubic system or cubic unit cell, is same or equal. That means A is equals to B is equals to C. That means all edges of cubic unit cells are same, as well as the angles, that is alpha, beta and gamma, all angles are equal and it is of 90-degree measurement. That means the all angles which is present in those unit cell, cubic type of unit cell, are same and it is of 90-degree. See here, observe here, it is one of the example of cubic type. Then see here edge length A, B and C, that is length, breadth and that is width, all are of equal length. And see here alpha angle, beta angle and gamma angle, all three angles. See here all three angles which is of 90-degree. Then that is the one of the type of unit cell, that is cubic unit cell. Then see here we will discuss detail about the cubic type of unit cell. All of you have studied that there are three types of cubic unit cell. That means cubic unit cell is of simple or it is of primitive type, which is known as SCC, that is simple cubic unit cell. And one more, that is body centered unit cell, which is known as BCC. And see here face centered unit cell, cubic unit cell, which is known as FCC. Then see here in the simple cubic unit cell, here total 8 particles are present at each 8 corners of that simple cubic unit cell. That means there are total particles are present at 8 corners of that unit cell. There is that type of cubic unit cell is simple cubic unit cell, that is STD. Then body centered unit cell, all of you have studied that there are particles are present at 8 corners. That means all corners of that simple cubic of that cubic unit cell in BCC, that particles which is present at 8 corners, as well as one extra particle is present which is at inside the body, that is inside the body of that cube. That means see here, if it is a cubic type of unit cell, then there are 8 particles present at each corner. Then see here, at each corner of that unit cell, as well as there is one more particle which is present inside the body of that unit cell. Then one more particle which is inside the body of that cube. Then FCC, in FCC there are particles which is present at 8 corners, as well as there are particles present at 6 faces of that unit cell. That means total there are 6 faces. In FCC there are particles which are present at 8 corners, as well as there are particles which is present at the center of each face. There are total 6 faces of that unit cell. Then those 6 particles which is present at the center of each face of that unit cell, then that unit cell is known as face centered unit cell, cubic unit cell, or it is known as FCC. Then we will study about the total number of particles which is present in those all type of unit cell. Then first of all, see here, number of particles, and all of you have learned about that. Particles means it may be atoms or molecule or ions which are present in the unit cell. Then here we have to calculate the number of particles, total particles present in the simple or primitive cubic unit cell, that is SCC. Then see here, in simple cubic unit cell there are particles which is present at each 8 corners, and when this type of unit cells, these are stacked together in the crystal, while formation of crystal like this, many cubic unit cells are stacked on each other. That is, when these are stacked together, then one particle, see here, one particle which is present at one corner of that one unit cell, it shares other 7 unit cells. That means here one particle at each corner of unit cell, it shares total 8 unit cells. That means it contributes in the 8 unit cells. Therefore, we can calculate the total number of particles present in the SCC. See here, 1/8 particle, 1/8 part of, that is 1/8 part of that one particle present at each corner, and like that there are 8 corners are there. Therefore at one corner 1/8 part of that particle is there, and that 1/8 part into 8 corners, 8 corners is equals to, see here, 1/8 into 8, that is 1. That means there are total 1 atom or particle which is present in 1 unit cell, 1 unit cell, because here in this one simple cubic unit cell, the particle which is present at that lattice point, see here, the particle or atom which is present at this corner of unit cell, it contributes in this unit cell of it 1/8 part of it. Like that, here 1/8 part at this corner, 1/8 part of particle at second corner. Like that, at 8 corner, it total becomes 1 atom which is present in the simple unit cell. That means there are total number of particles, that is 1 atom or 1 particle or 1 ion, it is present in 1 unit cell of that simple cubic unit cell. Similarly, we can calculate the number of particles which is present in the body center, that is in BCC unit cell. Then see here the total number of particles which is present in BCC type of unit cell. Then see here, BCC means body centered cubic unit cell. All of you have studied that there are 8 particles which is present at each 8 corner. That means at one corner 1/8 part of one particle. Like that 8 corners we get 1 atom or particle which is present at that corners of that body centered cubic unit cell, as well as there is one more extra particle which is present inside the body of that unit cell, which is present at that inside the body of that unit cell. Therefore that one particle which is present inside the body of that unit cell, it cannot shared by other unit cell. That means there is total 1 atom, extra 1 atom which is present in the center of unit cell. Therefore here total 1 plus 1, that 1 atom at corner of that unit cell and 1 atom present in the center of unit cell. Then 1 plus 1, that is 2 atoms, total 2 atoms are present in BCC type of unit cell. Then we will calculate the total number of particles which is present in FCC, that is face centered cubic unit cell. All of you have studied about that. There are total 1/8 particle present at each corner. Like that, at 8 corner total 1 atom or particle which is present in the FCC, and additional extra 1/2 particles. See here, extra particles which is present at the center of each 6 face of that cubic unit cell. Then see here, at each face there are, at the center of each face there are particles present on 6 faces. And see here, the particle which is present at the center of each face, which shares or it contributes to the neighboring only one other unit cell. That means the particle which is present at the center of each face, it contributes in this unit cell, that is one half at center of each face. Like that, total 6 faces are there. Therefore, 1 half into 6, that is 3 atoms which is present in the FCC at 6 faces. Therefore, there are total 1 atom plus 3. There are total 4 atoms are present or contributed in FCC, that is face centered cubic unit cells. Then that is about the total number of particles which is present in the 3 types of cubic unit cell, that is simple cubic unit cell, body centered unit cell, cubic unit cell, as well as face centered cubic unit cell. Then we can calculate the relationship between molar mass, density of substance, crystalline substance, and age length. See here, age length of unit cell, of that unit cell, of which that substance is made up of. See here, for example, if the gold crystal lattice or the unit cell of gold, it is of face centered cubic unit cell, then there are total 4 atoms present in the 1 unit cell of gold. Then we will discuss about the relationship between molar mass, density of the substance, and age length of the unit cell. Then let us consider A is the age length of given unit cell. Therefore, volume of unit cell is V, that is A into A, that is A cube. Then rho is the density of unit cell or substance, and m, that is small m, is a mass of that particles. Particles means the atoms, molecules or ions which is present in the unit cell. Then mass of the unit cell is nothing but it is a mass of particles, constituent particles, that is atoms, is the mass of unit cell. Because unit cell in which constituent particles are present in that unit cell, therefore mass of those particles present in the unit cell is the mass of that unit cell. Then see here, we have to calculate the relationship between that molar mass and density of that substance with age length of that substance. Then see here, mass of particles or mass of unit cell is equals to m into n, where n is the number of particles. See here, n is the total number of particles present in one unit cell. The small n, that is the total number of particles which is present in the one unit cell, and m, small m, is the mass of that substance or unit cell. Then mass of that unit cell we can calculate that m into n, because there are total n particles are there. Therefore, m into n is the mass of unit cell. Then density, Cm, density of unit cell. Density of unit cell, which is denoted by rho, that is density of unit cell is nothing but it is a density of that substance. Rho is the density of crystalline substance, of that crystalline substance. Then we can calculate the density of that substance or density of unit cell, that is mass of unit cell, mass of unit cell upon volume of unit cell, volume of unit cell. Then see here, rho is equals to, that is density of the unit cell is equals to mass of unit cell. See here mass of unit cell is m into n. Therefore, putting the value of that mass of unit cell m into n upon volume of unit cell. See here, volume of unit cell is V, that is A cube. Therefore, here V, that means m into n upon A cube. Let this equation number 1. Then all of you have studied about the molar mass of the substance. Molar mass of substance, which is denoted by capital M. Molar mass of substance, that is capital M. See here, molar mass of that substance means it is a mass of that 1 mole of particle. That means if that substance is taken 1 mole, if 1 mole is substance is taken, then mass of that 1 mole substance is the molar mass of that substance. Then see here, that 1 mole substance, any 1 mole substance, it contains 6.022 into 10 raised to 23 molecules or particles are there, or atoms are there, or ions are there. That means every 1 mole substance, it contains 6.022 into 10 raised to 23 molecules or atoms or ions or atoms. That means it is NA, that is number of Avogadro number, that is number of particles. Then see here, the particles, the molar mass of that substance is nothing but it is a mass of the 1 mole substance, means mass of 6.022 into 10 raised to 23 particles present in that substance. Therefore, here m, that is molar mass of given substance, is nothing but it is a m, that is small m, that is the mass of that substance into, there are total particles present in 1 mole of that substance is n. Therefore, m is equals to m into n. Therefore, let us consider this equation number 2. We get the value of m here, small m, is, that is m upon, m means molar mass of that substance, upon Na. Then putting the value of that m in this equation number 1. Therefore, then from equation 1 and 2, see here, we get rho is equals to, see here, m means capital M upon Na. See here, m upon Na is the value of that m. See here, value of that m, which is putting in this equation, into n means total number of particles present in the given substance, upon A cube. That means, see here, rho, that is density of unit cell. Therefore, we get rho is equals to m into n upon Na into A cube. That is the relationship between density of the substance, molar mass of the substance, and see here, A cube means that is edge length. A is the edge length of that unit. That formula gives the relationship between molar mass, density of the substance, and A, that is edge length of that unit cell of which that substance is made up of. Then we can solve few examples which is based on that formula or that relationship. Then the numerical examples which is given in the textbook, you have to solve, which is based on that formula. Then see here, the numerical example. Unit cell of AU, that is gold, is of FCC type, that is face center cubic unit cell type of gold crystals are there, and edge length of that unit cell, FCC unit cell, is 408 pm picometer. The molar mass of gold, that is 197 gram per mole. Calculate the density of unit cell. All of you are aware of that density of unit cell means that density of that substance. Then we can calculate the density of unit cell using that formula. The formula which gives the relationship between molar mass, edge length, and the density of that substance of unit cell. Then first of all, write the given values in this example. See here, the molar mass of AU, that is M, capital M, which is given here, that is 197 gram per mole. Then here total number of particles, N, that is number of particles, total particles or number of atoms present in FCC, that is 4, because in FCC 4 particles are there or 4 atoms are there, 4 atoms, as AU has FCC type of unit cell. And here the edge length which is given here, that is denoted by A, that is 408 pm. 408 pm means 408 into 10 raised to minus 12 meter, and or 4.08 into 10 raised to minus 8 centimeter. You have to convert the edge length. If it is given in picometer, then you should convert it into meter or into centimeter. The edge length, it may be given in nanometer also, then you should also convert it into meter or in centimeter. Then using the formula, that is rho is equals to m into n upon Na into A cube. Putting the value of those all, see here, a precaution should be taken that the units of all parameters should be in same system. That is, it should be in SI system or it should be in CGS system. Then rho is equals to, that is density of unit cell is equals to, here capital M, that is 197 into CF, then N, that is 4 upon Na. Na is nothing but the value of Na, that is Avogadro number 6.022 into 10 raised to 23. Therefore, here 6.022 into 10 raised to 23 into here the age length which is given here 4.08 into 10 raised to minus 8, and here a cube is there. Therefore, cube of that 4.08 into 10 raised to minus 8 cube. Then solving or simplifying those all, we get 19.27 gram per cm cube. Then you may solve this calculation using log table. Using the logs of those values, you may solve that example and get the value of density of unit cell. That is here, if we calculate, then we get 19.27 gram per cm. That is the relationship between density, molar mass and age length of the unit cell of crystalline substances. Then we will discuss about few more type of unit cell in the next lecture, as well as arrangement of the particles in the crystal lattice, which takes place in different ways. We will discuss about that in next lecture. Thank you.